When we're looking at the length of a line segment, a lot of people, a very common mistake I should say, is the first time you look at something like this is that students want to try to guess how long the line is based on what they're given on the page. So if we're looking at this and we've got our line, some students will start kind of measuring off how big it is and trying to guess based on that. But what we can actually look at here is that these lines, because we're given two coordinates, actually are going to create a triangle. Okay, so we can create a triangle all the way across this side and then all the way down this side. And no matter how the line is drawn, we can always create some sort of triangle. We could have looked at it this way where we were going up and then across. And no matter what we're looking at here, this is always going to be our x, this is always going to be our y. If we were considering the bottom of that triangle, our x would be here and our y would be here. The distances would be the same. So all we have to do then is find the distance or the difference between our x's. This is 10 and 2, so the difference here would be 8. That would make 8 at the top as well. And then the difference between 15 and 3 is going to be 12. And that would be 12 here. We could even look at the boxes and actually count that we have 8 boxes on the bottom and 12 boxes along the side. It would give us the same thing. The important thing we need to realize is that these create a right angle triangle. So if I wanted to find the length of this triangle, I could approximate, and let's see if we kind of keep going up and guessing. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, I know that that's not right because the hypotenuse can't be the same as one of the sides. So if I'm looking at this, right away I can tell that my guess is wrong. But I'm pretty close. The issue would be is, what if this isn't exactly a whole number? What if we have some sort of decimal? Then I'm in all sorts of trouble. But because we know it's a right angle triangle, we can use something like x squared plus y squared is going to be equal to our hypotenuse squared. A squared plus b squared equals c squared. And then my hypotenuse is always going to be the square root of x squared plus y squared. Okay, well, if I'm looking at that, in this case, we're going to have h is equal to the square root of 8 squared plus 12 squared. Well, then that's going to be the square root of 64 plus 144. And then my exact answer would be, the square root of 208. Now, we know we could reduce that down based on our last note. What if we made this root 16 root 13? Well, that's going to be 4 root 13. Now, unfortunately, some calculators will actually do this work for you, so we're not going to make you do this always. You could just leave it as this, but if we wanted to, we could always just find the square root of that and take a decimal, because oftentimes with length, we can round to 1 or 2 decimals and we'll get what we need. So this would be equal to approximately 14.4. Now, in this case, we'll just write units, but oftentimes you would have meters or centimeters or feet. And if you look, my guess here of 12 was actually off by over 2 units. And that 0.4 really would make a big difference. So if we were doing this in any situation in general, what we're going to do is I'm going to write out a formula. So the length of a line, so our length of AB, okay, the length of any line. And length is always going to be an absolute value. So we're never going to take a negative number, because when we're looking at length, we never have to actually consider this. So we're always going to have the absolute value of our answer. So we're going to have the square root of the difference in A minus B, or we'll go x2 minus x1 squared plus y2 minus y1 squared. And then we're taking the absolute value. All that means is that we're looking at a distance. We're looking at a positive value. If you wanted to, we could actually write this a slightly different. We could take the absolute value signs out here, and we could put them inside of our brackets and make our brackets absolute value signs, because we're actually looking at a distance between these 2 points. And that would be correct as well. So when we're looking at the length of a line, we're looking at the distance between 2 points. In this case, our x would be positive moving this way, but our y would be negative. So we want to look at a positive value because we're always considering the distance. And the reason that that's kind of going to be important is that if we gave you the length of the line, gave you the x values, and asked you to find the y values, you might find a negative value. And we want to know that a line, a length, is always going to be positive. Looking at this final question, we've got the length of PM, where P is -2, 1, and M is 4, -3. So the length of PM, if we're looking at that, is going to be the square root of our x's. So I'm going to start with M, and then I'm going to go back to P. So 4 minus -2. We'll put all of our substitutions in brackets. Squared plus, I'm still starting at M, -3 minus 1 squared. So this is going to end up being the square root. 4 minus -2 is 4 plus 2. So we've got 6 squared plus, and we'll put that in brackets, -3 minus 1 is going to give me -4. When I square that, it's going to become a positive number. So we're going to get the square root of 36 plus 16, which is going to be the square root of 52. Now we could always reduce this down. I'm not going to in this case, but if you wanted to get an approximate answer, all we actually have to do is square root that value, and we're going to get 7.2. Now let's say you were questioning yourself, and in this case, again, we'd be saying units. You'd be questioning yourself, well, I know that the square root of 49 is equal to 7. The square root of 64 is 8. This is much closer to 49 than it is to 64, so 7.2 is approximately right. I can also tell that the length here is 6 and the length here is 4. So being bigger than both of those values is important because I'm finding the hypotenuse when I'm finding a length. We're always making this into a triangle. If we consider just the points, if we were to roughly sketch them, P would be -2 and 1, which would be here, and M would be 4 and -3, which would be roughly down here. Our line looks something like that, but we're creating a triangle. We're making a right angle triangle. So this length that we're finding is always going to be a hypotenuse. It needs to be longer than our x and longer than